Hello everybody, welcome back to the workshop. So in this video, I am going to continue on a little bit of a series that I am on to here recently, because this is a job that I've had to take and do this week. And I am going to be making some chasing stakes, or repousse stakes, French repousse stakes if you will, to make acanthus leaves. Now I've already got a few of these made up. I've done a few of these in different videos. The ones that I'm going to focus on today are the actual veining stakes themselves. This goes in here to take and produce the center ridge vein, and you work down over the top of the stakes to take and produce this form with a smaller hammer on top. But we're going to be working on these veining stakes today. I'm going to make one more. This design here I actually pulled from a guy, Ironworks. You can check him out over on Instagram. I'll put a link in the description to him over on Instagram. I got this ideal from him, and I believe he got this ideal from Mark Asbury, but you can't quote me on that. So big shout out to him, and thank you for the great ideal. He did a post on Instagram about using this specific styling, and it just made a lot of sense. So let's go ahead and get right into it. Okay, so before we begin on this forging here, this is the shape that we're going for. We are making these veining stakes. In the previous video, we made these ball stakes here. As you can see, they're double-ended and they're made to go in the vise. That's why we have this recess here, and that's why we have a block here. We're going to hammer down over that block to take and create that recess, but not until we do our finials or our working ends of our tools. As mentioned before, this piece here started off at about 6 inches in length, or 150 mil long, and it's roughly 5/8 inch round bar 5160. Also mentioned, I am not heat treating these, I'm just normalizing these tools, as they just need to be tough and they are to support work and not actually be hammered upon. So they just kind of support the piece and you hammer off to one side. So they will always be protected with something, and since they have long times where they sit in the heat anyhow, it's really not necessarily necessary to heat treat these. But if you want to, you need to follow, and you're following along and you get yourself some 5160, you need to follow the manufacturer's recommendations for 5160 if you're going to do some heat treating. So we're going to focus on this tool here today. I've already got a 1/4 inch radius fuller on that end for the veining stake, and I already have an 1/8 inch radius fuller for a veining stake on this. The one I'm going to be making today is going to be a 3/8 inch veining tool to 1/2 inch veining tool. So that's what we're going to work on now. Hopefully it's good and hot, and we'll bring it out. So I've already cut my piece to 6 inches long, and I'm going to start with what's going to be the 3/8 in first. As you can see, this won't take real long at all, since it's very close to size and dimension. I'm actually just hammering it down much in the same way that you would do a slit chisel or any sort of chisel or fuller. We want to make sure that it's good and symmetrical. Not asymmetrical, but symmetrical. And make sure your flats are nice and clean. The cleaner you're forging, the easier this will be to file or grind later. So give that just a small brush. So now, just like that, our 3/8 in is done. One quick word of advice: forge down a little narrower than your target final dimension, because you remember we have to grind this back into a 3/8 inch radius. So forge it a little smaller and then grind back into that 3/8 to get it perfectly accurate. We'll flip this around and we'll do the other end to 1/2 inch. Got the other end nice and hot, perhaps a bit too hot, but now we're just going to barely forge that at all, because we do not need it to take and be forged down too dang much at all. So this right here is perfect. Clean it up a little bit back here on this end. Make sure she's squared up. And that's it for that end. If you want to get fancy with this, you can obviously make these opposite of one another. So you can make this one this way, this one horizontal, make that one vertical, this one horizontal. It's really not necessary. Just the main requirement is so this way you can flip the tool around and get it into the angle that you need. Next process, we will be coming right over here to the this radius block right in the end. Now take your time on this part. Let's find a place about center of the piece. Work on the far side of your radius block, and then on the near side. And then work across the block, back to the far side. That's going to start our shouldering area that we need. We'll go ahead and straighten this up a bit. Square that up. We're going to end up getting this hot again, which is good. And get it hot again, and we're going to refine that shoulder. Okay, refine that. Find your shoulders again. Square that back up. Kind of got a little twist in it. You want to make sure that these two surface planes are close to being square with one another. Drop it on the floor once for good measure. Good luck. And now we need to start squaring these back in line. And that's really all that there is to it. We're just getting this cleaned up to where the kinetic energy can flow into the jaws and not into a bend. So we don't want it to be bent. We want it to flow through. The kinetic energy, we want it to flow through. If this is bent out of order, it's going to come through a joint and it'll cause a crack, most likely right at the jaws of the vise. We don't want that. Clean that up a little bit. And I'm going to go ahead and just refine that a bit more, and then we'll be over at the grinder. Okay everyone, so here we are at the vise. Went ahead and got all that straightened up, and it's looking pretty good so far for just being forged to finish right off the anvil. I could have took a little tidier job, but again, you can make it as pretty as you like. The thing that we're wanting to focus on though is the working end of the tool to take and do the job that it was designed to do. So that's what we're going to work on now. As I've said in previous, we want just two different size ends of this tool, and so therefore they're going to be ground a little bit different. One was left a lot thicker, so this way it's going to have a much broader radius to it, as where one was forged a lot thinner, and therefore we're going to have a much tighter radius. I've already taken and squared this up ever so slightly over on the belt grinder, and now we're going to go ahead and use the angle grinder here with a 320 grit Diablo brand, not a sponsor, 320 grit sand pads here on a little sanding pad for this. I've got my Bosch angle grinder set down on level 1, gear 1, whatever you want to call it there. So this way it's moving very slow, so I can do a really good clean job of this. I really like using this method to clean these tools up versus like flap discs or things like that. It's still very fast, but it leaves a really impressive 320 grit finish, which is perfectly fine for a working tool that's going to be engaging hot steel. Again, later on I might polish that to a high polish, but this is a good start. So let's go ahead and get started. Okay. So I'll stop there and talk about this for just a second. So I want to alleviate the beginning and end edges of this tool. So the leading and the receiving end of the tool. The reason for that being is sharp corners leave chop marks on the underside of your work as you're hammering there. And we don't want to create chop marks. We want to alleviate all corners around the edge of this fullerene stake here. So that's what we're doing essentially with this tool. As you can see, it doesn't take long because we forged the end of the tool to roughly the size dimension we want. So it doesn't take long with 320 grit to do this. So let's get back at it. There we have it. So basically, it's just that simple. Really, I want to encourage you not to overthink making tools like this. This is a very simple thing. We're looking for a very simple form. You know, you can really overthink something like this to no end, having to get it perfectly geometrically perfect and all this other stuff. Don't worry about that. You can always refine this at a later date, take a little extra sandpaper, clean things up a bit. You know, you can always come back in. This is very low friction. It's a very low friction environment. It's not a frictionless environment, so you know it will still build up heat because it's 320 grit sandpaper. But for the most part, you can just keep your pads changed here and really clean this up very expediently without wrecking a temper. So say if you did harden and temper this tool first before going to this step, this is a great way of doing it on, you know, a little variable speed angle grinder. By the way, I'll just mention real quick, if you are looking for a tool like this, I'll have a link in the description. It's an affiliate link, full disclosure there. If you buy anything through that link on Amazon, I get a little kickback for sending you their direction at no additional cost to you. So it's a great way of supporting the channel if you're in the market for a tool like this. If not, totally understand. You can use that link to just go check it out and buy it at your local hardware store or find at least the model number. So I'll have that down in the description and the brand of the, you know, the pads here that you can hopefully locate or find there on the net. So let's get back here. Let's go ahead and finish grinding this one up and we should be all good to go. All right, so there you have it. That's basically got that done. We took care of the leading edge and the trailing edge as well of this tool, so now it shouldn't leave any marks or mars whenever we're forging our piece on here. The last thing I'm going to do is I'm going to take some additional or slightly wore out 320 grit sandpaper and to take off any sort of flats or facets that I got from this sanding pad, because it will leave little flats. I'm just going to run that over the tool just like so. And what that will do is that will help remove any of those and produce a much evener, a much smoother finish in the long run. So I'll just do that real quick. And that's really going to get this thing pretty darn shiny and perfect tool for use now. So like I've said in the previous video, forming of the ball stake, and the other type of tooling videos, I'm not heat treating this. You can certainly, And I may decide to in the future, just depending on how these tools react. Again, these are forged from 5160. I do not believe I need to actually heat treat this tool because I'm working very thin material that's going to be hot that I'm working against this tool. So I just need a tough tool. I need the toughness of the 5160, but I don't necessarily need the hardness of this tool. So that's that's just a personal choice of mine. Now, obviously, there is no argument about it. If you want a tool that's going to last an absolute lifetime, go through all the processes of properly heat treating your tools, ladies and gentlemen. That's the only way that you can ensure that you're having a proper heat treatment, but that is very difficult to do considering that most people don't have heat treating ovens and cannot sustain the temperatures for the amount of hours that a lot of these newer tool steels require. So when you're doing it in your forge, it's a little bit of a guess. It's a little bit of a guessing game. It relies upon your personal skills and your personal experience with heat treating. That means you've done it a bunch, you've tried it a bunch, you've seen what works and don't work through trial and error. And so there's no way around that. I just know that this is a very tough steel that doing the type of work that I'm requiring of it, it won't require the heat treatment. But without going too much into that, if it does at a later date, I can always normalize this tool a couple times, maybe anneal it to take out any working stresses that I have, clean it up, and then go ahead and harden and temper these. No problem whatsoever, as long as there is no major structural failures, which there shouldn't be. So there you go. There you have it. I hope you all enjoyed this video. If you did, hit that like button. Let me know what you thought of it in the comment section down below. And as always, God bless you, and we will catch you on the next one. Thanks for watching.